So let's review the steps for using the calculator to find the mean, the standard deviation, and the variance. Now remember, you have the worksheet I just gave you, the little cheat sheet on calculator steps. So you can use that. So follow along. You want the side where it says calculator steps for variance and standard deviation, kind of the black by the holes. So you can follow along so you can read what this is telling you to do. We already put the stuff in the list. And now we press stat. We move over one to calc, one variable statistics. Depending on the calculator that you have, you can either leave it blank if your calculator looks like mine, or you have to type in L1. So, because I'm working with L1. So you hit enter. What's my mean? What's my standard deviation? Do it to the nearest hundred. 4.73 to the nearest hundred. 100 means 2 decimal places. You look over one, that's a 5, and you bump that up. So just like that, that's it. You have found the mean, you found the standard deviation. Easy, right? Yes? Well, if you want variance, you would square this. There's two ways to deal with variance. So 4.73, right? Approximately. So 4.73 squared. That's approximately your variance. Does anybody remember the more exact, precise way to get variance? Remember? What do we press to get? And it's on here. It's on here somewhere. Yeah, finding variance. It tells you kind of the, yeah, what do you press? Bars. You just look at the list of statistics, right? That's what we're doing.
Wait, what?
Number 5. Bars. It's to the left of the clear button. All right, now I want my standard deviation because I'm going to square it. That's number 4. There it is. Go ahead and square it. And see, they're very close. This one is more precise because we used the number that the calculator calculated for us. I will accept either one if I ask you for variance. Either one, I will accept. Yes? The square button is you move one left from the 7 and then up one. Right? We used that on our last unit, the square button. See it? Yeah. Okay. So those are easy. Everybody should be able to do this. And the reason I need you to be able to do this is the goal isn't can you find the standard deviation. The goal is can you use the standard deviation. I need you to be able to find these quickly. Okay, now MAD is a limited story. MAD we don't use so much. It's more just can you find the MAD? Do you understand what a MAD is? So the calculators that we're using don't calculate MAD. The best way, the easiest way, is to expand the formula on the formula sheet. Now, if you are super duper interested in how to use this calculator, anybody super duper interested? Yes, we have a few people. I'm going to show you how you can use MAD. If you flip over that paper I gave you, there are steps. So if you follow along while we do it, this will make more sense. Yes, sir? The standard deviation, you do a stat calc, one variable statistics. You see that little sigma? That is your standard deviation. Square that number and you have variance. Does that make sense? Yes? Jerry? Acknowledgement. Okay, thank you. Now, how do you find MAD using a calculator? It's a little bit more complicated. So those of you that are really with me, watch this. If you're finding your head starting to spin, oh, I can't, then it's okay. Just do it by hand. This is really just my superstars who just really want to know these calculator steps. So watch this. Do a stat and an edit. We're looking at our list. And I'm reading what it says. It says go into the list one, put it in. Now you must do a stat calc or this will not work. Now I know we just ran it, but it's to get in the habit. Once you put it in L1, do a stat calc 1 bar stat. Then go back in. The reason I need to do that is I'm setting the bars in my bars button. So I have to set them first. Now I'm going to go to list 2. How do I go there? You take the right arrow, move right. Take the up arrow, move up. And then you hit enter. And see where my little cursor is? I'm right over here blinking on the bottom where it says L2 equals. Alright? Now what I'm going to put in list 2 are all the distances. I'm going to put in the absolute value of each x minus the mean. So I have to find absolute value. Here's how you find it. You press the math button. You move to the right one where it says num, and you should see your very first choice is ADS. That's absolute value. Once you see that, you can hit enter. So what do I want the absolute value of? I want the absolute value of everything in list 1. So I'm going to say list 1. Remember, press that second button in 1. Minus each x minus the mean, right? Now, if the mean's a nice easy number, you can just type it in. What was the mean for this one? 93. You can just type in 93. Or, I'm going to go back now and delete that 93. Because there's a way to get, from the calculator. And it's our friend bars. So if you hit bars, and you go to statistics, last time I wanted standard deviation. What do I want this time? The mean. So that's number 2. And so I should see absolute L1 minus x. What that's, or x bar. Take the absolute value of everything in list 1, subtract the mean. So when I hit enter, watch what happens.
How do you get it out?
Bars. I'll do it one more time. So relax if you didn't get it the first time, just watch. Now you know what these are? What are these things? The distances. So how do I find mean absolute deviation once I have the distances? What do I do? Why? No, how do I find that? I have the distances already. Find the mean. Find the mean of this list. How do I find the mean? Stat, calc, right? But I'm going to do which list? List 2. Stat, calc, 1 bar stats on list 2, my distances. So the mean of list 2 is 4. That's too bad. Yes. Yes, it is. So we looked at calculator steps to figure out the math, mean absolute deviation, standard deviation, the variance. So if we can recall what those things are, mean average deviation and standard deviation are measurements of what the average distance each point is from the mean. What does it mean if you have a really big MAD? What does that say about your data points? Right, they're very different, right? Some could be big, some could be small. What if you have a very small standard deviation? What does that mean? They're close together, they're consistent, right? That's another word for that. So that's what those things are kind of giving us some feel for. So standard deviations give us an idea how typical, how consistent, are our data points. We have a huge standard deviation, they're not typical to each other. If we have a small one, they are very close together. Now we want to answer the question, how close to the mean is an element? And we say an element is so many standard deviations away from the mean. So if you recall what we did, one of the early examples was we had a family, the mean age was 14, and we had some kid who was 10 years old, right? And we said, see, how far away from the mean is he? We said he's 4 years under the mean, right? You're 10 and the mean age is 14, aren't you 4 years under the mean? 4 years under the mean. So we're using the units that kind of go with what we're looking at. Now we're going to start counting by standard deviations. Now we didn't calculate the standard deviation, and I'm totally making this up. But let's pretend the standard deviation for that particular data set with the ages of the kids was 2. So on average, each kid is around 2 away from the mean. That's what that means. So how many standard deviations is this 10-year-old from 14? 2. How'd you get 2? Well, no. It does say 2, but if you think about it, he's below the mean, isn't he? So we would write he is minus 2 sigma. He is 2 standard deviations below the mean. Now, how did I get that? So let's make a number line here. Here's my mean age of 14, right? This kid is 10. So if I was 1 standard deviation below, and each deviation is 2, where's 1 standard deviation? 12. Exactly. Now if I'm 2 standard deviations below the mean, I have to go another sigma, right? So how many standard deviations from the mean is my 10-year-old? 2. You were right. Now you're right for the right reason. is the z-score of 10 for this particular piece of data?
2.
The z-score is
2 sigma.
why is it minus 2?
Negative. Because negative
Is 2 under. 2 standard deviations under. That is z-score. That's it. That's it.
Yeah.
That's it. That's hard. Tell me what's hard. I don't want it to be hard. Well, this is, I'm trying to kind of figure out a continuum. It's a number line. Now, what would be one standard deviation above my mean of 14?
1 sigma.
Now, look, let's look. It's 1 sigma. Where would I be over here? How old would somebody be? One standard
16.
How old? 16. How'd you get 16?
Because you added 2 sigma.
Yeah, these are minuses. Now what am I doing? I'm adding a sigma. So somebody who is 16, he is now 1 standard deviation. How old is somebody? 2 standard deviations. How are you getting this, Alex? You're just getting like that. Well, that's it. It's funny because that's all you got to do. Now, here's this one's a little more tricky. You ready for tricky? We're ready for tricky. Oh, no. Yes.
Yes.
What age are you 1.5 standard deviations above the mean? 1.5.
17. No. 7. Yes. 7.
Well, explain. Emma, how are you getting that?
1 is 2.
So what's 1.5 of 2? 3. So I count the whole. Duh. What's it duh? Well, it's not, I think it's not duh at all. You gotta really think about this. This is big stuff. This is big time, big girl, big boy math. Yeah, so that's what z-score is. Now we're gonna have formulas. Right, look at your formula sheet. Anybody find the z-score formula? Yeah, you didn't look, so yeah, no.
That's
That's it. All right, so tell me, Ishan, what is the formula for z-score?
Z-score?
Yeah.
Equals x minus 5 sigma.
What is that little thing? It sounds like a Greek cat. Greek cat. U.
Divided by
What is that little thing? Sigma. Just x minus mean over standard deviation. X minus mean. Now let's think about this. Have we seen this before? Yes. What is that thing? What is that thing? What is that thing? Claire, what is that thing? I know you've seen it. Call on me. Call on me. She's like, I pass. What is it? Oh, we used it in math. What is that? It's, well, cool. What is that? Oh, think of my 10-year-old and the 14-year-old. I'm just looking at the numerator. The deviation. Right? That's when you take a number and you subtract the mean. But I don't want to know how many years away, right? I want to know how many standard deviations. What is this thing? Standard deviation divided by the standard deviation. Let's do our ages. If I want to know 10, right? 10 minus the mean. What was the mean again? 14. What was that standard deviation?
negative 2 sigma.
So 10 minus 14. Did we say the 10-year-old was 2 years under the mean?
Yeah. 2 sigma.
I think that was a good one. Was that a good one?
Negative 2 sigma. Negative 2 sigma.
Yes, ma'am. Okay, just a moment. Just a moment. We'll go to lunch in a second. Before we break, I want to make sure we're on track because it starts looking hard. It starts looking hard until you remember we're just counting by standard deviation. We're counting by standard deviation. Repeat it up to me. We're counting by standard deviation. That's it. That's z-score. All right? We do need to go to lunch, my friend. But thank you very much. Now, you guys, if you can come back as soon as you can, we're going to pick this up where we left off. Okay, you need to know what a z-score is because we're studying z-scores, whether it's on the test or not. Maybe it is, maybe it isn't. All right, so here's an example of a z-score question, a set of values. Now, are they telling me what all the values are? No. But I know this set of values has a mean of 85, and I tend to rewrite some of the important things. The mean is 85. The standard deviation is 6. Find the z-score of the value, 76. So what does this mean? This is a value. So what does it mean by it's a value? Value of what? Value of what? Yeah, of the data set. This is an x. Because remember, all the data points are called x. So if I want to figure this out, I have to kind of really understand the question. So here's again a number line. Here's 85, right? That's my mean. One standard deviation above, in this case, it's 6 above. So I take the 85 and I add 6, and what do I get? 91, right? That's one standard deviation above. What would be two standard deviations above? 97. Now if we go the other way, we're going below. So 6 below 85 would be where? Right? That's one standard deviation below. What's two standard deviations below? 73. We're subtracting 6. Now where are these numbers coming from? Add 6. Add 6, subtract 6, subtract 6. Why 6? Because that's my standard deviation. We're counting my standard deviation. Now let's look under this little picture here. It's hard to see. 76 is somewhere over here. So if I was to guess the value of the z-score of 76, how many standard deviations? Now is it going to be above or below the mean, 76? So it's going to be negative, right? Approximately. What do you think? Well, it looks to be about negative 1.5. It's hard to tell from the picture. So let's see what happens if I use my formula. Z-score is found. First, find that deviation. Take the x, subtract the mean, and then divide that whole thing by the standard deviation. So my x here is 76, because that's my value. My mean is 85, and my standard deviation is 6. Now you can use the calculator for this. I mean, most of you can do that in your head. But when you are using the calculator, be really careful with the order of operations. If you type in 76 minus 85 divided by 6, is that correct? What's the problem if I just did this? What's the problem, Jerry? Right. It's going to do the order of operations, so that's not the right number. You have two options. You can put the numerator in parentheses and then divide. Or, this is what I usually do, I just say 76 minus 85. I hit enter, so it does that calculation, and then I divide by the standard deviation. So make sure if you're using the calculator, keep in mind those order of operations and do this correctly. And you were right, Claire. So what does this number mean? Negative 1.5? What is that? What is it telling me? How many standard deviations 76 is from 85? How many standard deviations is 76 from the mean? It's negative 1.5. 1.5 standard deviations below. Sometimes you put a little sigma here. 1.5 standard deviations, because I'm counting by standard deviation. Make sense? This is making sense for them. You got a few people. Okay. Here's another example. The following numbers are metabolic rates of 7 members who took part in the study of dieting. So these are calories for 24 hours, how much each of the people in this study were consuming. How many standard deviations above or below the mean is 1460? So it wants to know, this is my x, and it wants to see what's its z-score. That's what this means. How many standard deviations? Once you see that, that's a z-score question. So to find z-score, remember my formula. So x they're giving us, that's 1460. Well, what else do I need? The mean, standard deviation. Now, how do I go about finding that? Right? Do we want to spend a long time squaring things and, no. You go right to your calculator. So this is what I've been meaning about, I don't want you spending 10 years trying to find the standard deviation. Put all the numbers in the calculator. And this should be on your paper, so you can do this too. 1792. 1614. 1460. I'm just putting in, once they're in, check them let's say it didn't. Okay, we're working this problem, right here is blanks. So I'm just doing this first part where they're blanks. Now, how do I find what I need? Stat, cal, one variable statistic, depending on which calculator you have, you might have to type in the list. This one I don't have to. So what's my mean? 1600. Well, here's my standard deviation right here. And then, you know, 175.2, right? 1600, 175.2. Now, how am I going to figure out how many? Now, is this going to be above or below the mean 1460? Which is it? Below, because 1460 is less than 1600. So it's going to be a negative number. How far below? Well, I use my formula. X minus mean over standard deviation. The X is the 1460. The mean I just calculated at 1600. The standard deviation, 175.2. I am going to use a calculator for that. 1460 minus 1600 divided by, notice how I hit enter there so that I get, you know, the accurate order of operation. Approximately negative 0.8. So what does that mean? That 1460 is approximately negative 0.8. It's 0.8 standard deviations below the mean. Almost a whole standard deviation below the mean, not quite. And let's look at a picture again. Let's look at this number line. So here's my mean of 1600. If you add 175.2, let's see what we get, because I'm not sure what that value is. I'm going to add 175.2, one standard deviation above. I'm at 1775.2. And if I go, how do I find where I am one standard deviation below? Subtract it. So we're using bigger numbers than we were using before, not 2 or 6, but they mean the same thing. So if I'm looking at 1600 and I want to know 1460, that's somewhere over here, right? Does that look about right? Does that look about negative 0.8-ish? Yeah. So just kind of visually seeing it sometimes helps us think, what am I really trying to find here?
Is this goes negative 0.8?
Yeah, isn't it?
Yeah.
I'm almost. I'm not quite one standard deviation below, but I'm getting there. Negative 0.8. So now look at this question. How many points are within 2 standard deviations from the mean? Well, before we do that, how many points are within 1 standard deviation of the mean? If you are between 1424.8 and 1775.2, you are within 1 standard deviation of the mean. You're either above it or you're below it, but you're within 1 standard deviation. So let's do it for 1 standard deviation. 1792. Is that point within 1 standard deviation? No, because the top is 1775, right?
Oh.
Too big. No. How about 1666? Is that, yes. How about 1362? Is that within 1? How about 1614? Yes, right? How about 1460? Well, yes, we just did that one. 1867? No. How about 1439? So how many points are within 1 standard deviation of the mean? 4. So 4 points within 1. Now let's say I want to find 2 standard deviations of the mean. So how would I do that?
Double it.
Double what? What for? What? Well, what's my standard deviation?
175.
So how do I know where 2 sigma is? What do I have to add? I have to add another 175.2 to that limit up here. So I'm going to take that 1775.2. I'm adding another standard deviation. Just because these numbers are big, so what? I'm going to be over at 1950-ish. This point something. But that's 2 standard deviations. What about the other way? How am I going to find my limit going this way? Subtract it from that other limit. So 1424, subtracting a standard deviation, it's about 1250. I'm just going to make it 1250 just to make it slightly easier. So over here somewhere at 1250, that's another standard deviation. So to be within 2 standard deviations, you're between 1250 and 1950. So how many points are between 1250 and 1950? Well, that one is. Well, that one, if it's within one, it's going to be within two, right? Yes. Yes, all seven. So all 7 points are within two. Now it's asking another question. How many points are within 1.5 standard deviations? Now we did this with the simple example, right? So how do we do this, Claire? And then add it on. Another way of doing that is you can take the standard deviation and multiply it by 1.5. That's going to tell you how far above and how far below. So let's do that. So 175.2 times 1.5 is 262.8. So I'm going to go back to my mean of 1600. I'm going to add, you're going to subtract that value to find where are the limits for 1.5 standard deviations. So let's see, 16, I forget the number already, 1600 plus 262.1. So that's 1862. Just writing my boundaries here. And then I subtract that, 1600 minus, what was it, 262? Is 1337. Let's just make it 1338. Oops. It's getting a little messy. But these numbers here are the boundaries for 1.5. So now you look at every point. Does 1792 fit in here? Yeah? Right? 1792 is in that boundary. If you're within 1, you're within 1.5. How about 1362? 1614, yeah. 1460. How about 1867? No. 1439, yes. So this time looks like 6, right? So you can figure out how many points are within so many standard deviations. You add it above, you add it below, and just kind of compare the points. That's one way, I think the easiest way to see it, what we're asking for. Okay, let's look at another kind of problem, because why would we ever use this? It is a good question. Z-score is actually used an awful lot in the real world statistics. This kind of analysis, standard deviation, used an awful lot. We'll see some more examples soon. But let's look at this one. So I've got John and Fido. John is Fido's human, and Fido is John's dog. John weighs 220 pounds, and the dog weighs 90. Now, the human males have an average of 160 pounds with a standard deviation of 20. And dogs that are like Fido, the same breed, their average weight is 80 pounds with a standard deviation of 5. So let's see what I got here. For John, the average is 160, right? And the standard deviation is 20. For the dog, for Fido, his average weight for his kind of dog is 80 and the standard deviation is 5. Now what's their actual weight? This is a data point, right? His actual weight here is 220. And Fido, his actual weight is 90. Now if you look at it, my basic question is, how do they compare? I want to know who's fatter. Well, I mean, basically that's what I'm asking. Now they're both overweight, right? Now 10 pounds doesn't seem like a lot. For a human, 10 pounds, it's not great, but it's not terrible. For a dog, and especially if it's a smaller breed, it's not a lot. And I think of my cat, like if a cat gains 2 pounds, that's enormous. But if a person gains 2 pounds, you can't tell, right? So it's different. Pounds kind of mean different things whether you're a dog, a small dog, or a person. So we can't really just say, well, this one's 10 pounds and this one is 60 pounds. It doesn't compare in the same way. So what we're going to do is we're going to compare their Z-score. How far above or below, or they're both above the base, are they relative to what's normal for their species? So if I'm looking at John, let's find his Z-score. Z-score is the x minus the mean over the standard deviation. What's my x? He's 220. The average is 160, and the standard deviation is 20. So that's 60 over 20, which is 3. 3 what? What does that mean? 3. What is that telling us?
3 standard deviations only.
He's 3 standard deviations above the mean. So think of that. So there's an average weight that we think people should be, and it's based on, I guess, weights that they gather. So average, most people are this. 3 standard deviations above, that's kind of a lot. That is. Let's see how the dog is doing here. So So he's also x minus mu. So he's 90 pounds. Average dogs are 80. Standard deviation of 5. That's 10 over 5. He's 2. 2 what? What does that mean? 2 standard deviations above the mean. So relative to their population, who needs to die at first? The dog? What? He's 3 standard deviations above. That's 3 of those marks away from normal. I'm saying normal, average. Whereas the dog is 2 above. Who's in worse shape? The human, right? You don't want to be 3 standard deviations above the mean when it comes to weight, do you? No. Well, I mean, if he diets, we have to do the x will change, right? If they both lose weight, the x will change. We can see how they're progressing. So it's a way to compare things that otherwise we couldn't compare. So that's one use of z-score, is to kind of, mix things on an even level here, even playing field, that we can compare the two. So that's one use. How about this one? Given a set of data with a standard deviation of 3, and I do like writing it out, standard deviation of 3, and a mean of 9, what would the value of an element be if the z-score is 2.5? So what am I looking for here? They're giving me the z, they're giving me the mu, they're giving me the sigma. What do they give me? The x, the data point. That's what they want me to find out. So how would I do that? Replace what you know and solve for what you don't. Z was 2.5, the mu was 9, the sigma was 3. How do I solve this equation, friends who just took an equation test? Yes? What? Algebra, yeah, so what should I do? Yay, algebra. What do I do? What should I do first? What? Well, but I can't do that. I have to do something here too. Remember, this whole thing is over 3, so I can't just pick a piece of it out. So I don't know if this is what a lot of people have trouble with. If I do this, does that give you a clue? If I do this? Well, I'm thinking cross product just because it might be easier to see. So x minus 9 equals 3 times 2.5. Or you might be able to see that you can multiply both sides by 3 because that will cancel this out. What's 3 times 2.5? 7.5. We add 9 to both sides, right? Right? So this x is the value that is 2.5 standard deviations above the mean. That's what that is. So sometimes it's not the z-score we're finding. We know the z-score. We want to find the value that has that z-score. So that's what this is demonstrating. Again, we're looking on one of these kinds of things here. So they gave me the z-score is 2.5, right? That's about here, isn't it? Because there's 2 and 3, so 2.5 is about here. Yeah, 16.5 is about right?
Yes.
Yeah. So that's what we're doing. So sometimes they give us this value and you have to find this. Sometimes they give you this value and you have to find that. These are the z-scores up here. And these are the x values. Make sense? Not make sense. It makes a little bit of sense. What else do I have here? We're almost done here. So these are some you tries. Find the z-score for a data value of 15. We're on the back here. Let's see if we can actually work these out. We'll talk in a moment.